If one wished to avoid the use of HCl or HBr, both of which are strong acids, in the reaction of alcohols to produce alkyl halides, you could also use SOCl2 with pyridine instead of HCl, and you could use PBr3 instead of HBr to convert either primary or secondary alcohols to alkyl halides. The reason why we have to have a primary or secondary alcohol is because both reactions will rely on an SN2 reaction, and we need the alpha carbon to be relatively unhindered to allow SN2 to take place. Let's look at the mechanism. First, we'll look at the conversion of an alcohol to an alkyl chloride using SOCl2 and pyridine, which we abbreviate PYR. So let's draw out the alcohol with its lone pairs, and then we need to know the structure of SOCl2, and also want to fill in all of the lone pairs when drawing a mechanism. And the sulfur in SOCl2 is very electrophilic, and the alcohol, which is nucleophilic, can do a nucleophilic attack. It's possible this is a two-step process called an addition-elimination, but it's also possible that this first step happens in a SN2-like concerted process. And that's because sulfur is much larger than carbon, and so backside attack on sulfur may be possible even when it's sterically hindered, like in the case of SOCl2. So let's draw what we formed. And again, all of our lone pairs. Okay, and we kicked out some chloride. In this case, we've included pyridine, which is a stronger base than chloride, and it will also prevent the formation of HCl in the reaction. So when pyridine's present, it can act as a base to take this proton, instead of Cl taking the proton to form HCl. Now chloride can do a nucleophilic attack on this relatively unhindered primary carbon, and this large group will be the leaving group. So we'll form some SO2 gas and also some more chloride. So we formed our organic product, the alkyl halide. Again, we formed SO2 gas as a byproduct, and we also formed some pyridinium chloride as another byproduct of the reaction. Let's look at the mechanism of conversion of a primary or secondary alcohol to an alkyl bromide. And again, we would probably use this reaction if we were trying to avoid using HBr, which is a strong acid. We could alternatively use PBr3. So let's look at that mechanism. draw in our alcohol and PBr3. I usually like to draw in all the lone pairs whenever I'm drawing a mechanism. So I'll go ahead and sketch those in. Again, our alcohol is nucleophilic and the phosphorus is electrophilic because of its attachment to all of those bromines. So if the alcohol does a nucleophilic attack, we can go ahead and kick out one of the bromines attached to the phosphorus. So we'll draw what we formed. Now we have a good leaving group, right, where the oxygen can leave, and we've kicked out bromide, so it's in solution. So now again, since the alpha carbon is unhindered, we can have an SN2 reaction. And this is the leaving group. So let's see what we've formed here.